Hello. Sorry for the delay. It took me a while to get back. Welcome back to the latest episode of Learning Kotlin Live. And let me first check if we're live now. I Yesterday I streamed to Twitch actually for a while. Okay, yeah, we're live. Let me take a look. So this is where we left yesterday, and we're going to optimize this. Let's first review this implementation, and maybe we can later optimize it. So the question, first get back to the description. The question is how we can calculate all the cost of the available rooms, and the definition of an available room is whenever it is not below a zero cost room. All the rooms that are not below zero cost room are available rooms. So for this case, this 1, 1, 1, 5, and 1 is available rooms, and we add up all the costs there. So yesterday we have multiple lists of topmost zeros, and we initialize it with 6, which is kinda not optimal here, because I mean maybe not that scalable, because this 6 is set up due to the constraint that every run cost is lesser than actually not. It is assuming that the room is going to be less than 5 floors. So the building is going to be less than 5 floors, less than or equal to. So this is not scalable. So a simple way to fix this is the one that we have last time: Kotlin max number. So no, not this, max value. So this is one way to do it. This is also my preferred way to do it, because while one can argue that -1 is definitely not going to be used, so it's better here, but for simplicity of implementation, because integer itself is not infinite. So if we're using -1, we're actually only having an extra item, I mean the margin, the boundary of the how do I say this? So with the max value implementation, our logic is safe until the building is of this height. But if we use the -1 implementation, we're only safe until this, because when the input is larger than this, we still get an overflow. So this is my preferred way to do it, because for simplicity, if we're implementing it with this -1 implementation, we'll need a lot of special checks here and maybe here. Yeah. Okay, that's the algorithm part. So actually yesterday we're maintaining the topmost zeros, and then use these topmost zeros to decide what to add. Actually we can merge these two items. So let's first move this sum here up here, and this is for debug, so we don't need this. We don't actually need this. So we only add when we always add the items we get into the array until we find a 0. So if we don't need to maintain this anymore, so yeah, I think this is finished. That would be simpler. I hope I'm not missing anything. So when we reach a 0, we break, and yeah, this is better now. So one mystery unsolved is this topmost 0.fill is not working yesterday, and I think it's not working because the initial the capacity are not reached. So actually, I'm not sure if the Java implementation here is actually working the same way or not. But one thing that I really want to understand is the syntax or the fundamental working methodology or the Kotlin language design that supports this fill function here. Although this actually is not used in our day-to-day in this algorithm. Let's first take a look at this fill, and it's Kotlin standard library. Kotlin standard provides living essentials for everyday work with Kotlin. This includes higher order functions. No, we're not using this one. Various utilities for working with strings and char sequence, kind of like this one, for collection instead of string. So yeah, Kotlin. Collection types, iterable, collection lists, and yeah, that's where we have these. So there are some types, and where do we get that fill? Oh, it's in Kotlin.collections. So we will find a fill here, and it is a function, and okay, it is only supporting array. So is Java array list kind of an array? I don't know. So let's take a look at this array. Yeah, any array. So array, byte array, short array, integer array. Actually, I'm also interested in what's the difference between this array and array of any type and integer array. Are they interchangeable, or IntArray Kotlin? So array of integer under the hood, while int array is an okay. So is it really that simple? So something array is for primitive types. Byte is a primitive type indeed. Short, integer, long, float, double, boolean array, char array. Yeah, these are all okay. That makes sense. So these are just wrappers of the Java primitive types. And so how about integer vs Kotlin int Java integer? So it's int is a Kotlin class derived from number, and integer is a Java class. So they are not exchangeable. Cool. So integer will interoperate well with Kotlin int, but they do have some subtle differences in behavior. For example, integer and int. Okay, int3 does not compile. Okay. Compiles, and oh, this is an error, really? Oh, because it's a class, so it should be initialized. Yeah. Literal does not conform to the expected type integer. Yeah. So, oh yeah, okay. So it's different. So I believe Kotlin bytes are also different from. Okay, let's get back to these this field mystery. So the one we were using yesterday is actually this. It's a mutable list. So let's take a look if multiple list actually derives from array. Multiple list is it's extending list and mutable collection. So list is the more iterable. No, so it is not an array at all. No, it's only iterable. Yeah. So it's not an array at all. That's interesting. So why are we able to call this one? Maybe this one is not the one. Ah, and that's why. That's why we found that the class signature are different. We tried to use from index and to index yesterday, but actually maybe that's not possible. So let's take a look at multiple lists and let's see if it has a field. I don't think so. Yeah, no field, but maybe it's in the list implementation or mutable. I don't know. Collection. What about you? No, there is no field. How about mutable collection? No. No. So there is no field. That's interesting. So is it actually not possible to call this? But actually we have done this. It compiled anyway. Yeah, because it is of type mutable list, so it's not going to be about array list anyway. So yeah, it's from mutable list. Let's take a closer look and check it again. Mutable list, field. Nope, there's no field. And let's take a look at the two implementations. List and mutable collection. So this is already list and multiple collection, and they are all derived from collection, and also mutable, iterable, and they are iterable. So yeah, this is everything. If there is no such field, then only magic can explain what we have. What we have experienced. Let's see. Okay, let's Google it then. It's bringing us to, oh, there is a mutable list of fields. So where is it? No, we're not seeing it. But why is it in this? I don't know. Why is it showing up in this preview? Is it like only in, oh, maybe in 1.3? Ah, yeah, there it is. There is since 1.2 there is a mutable list dot field in Kotlin dot collections. And yeah, it does not have this from index and to index thing. So fill a list with the provided value. So yeah, because it does not have index, it's just filling everything it already have. So let's go back to here, and yeah, let's try to add something random here. Let's use -1 here. And add and initialize it into max.value. Although this is actually performing worse, but let's see if it's working. I hope it's doing its job. Yeah, it's doing its job. But let's just let's just minify this class. And yeah, that's everything we should do now. We have for now. Okay. This is minimized. And yes, let's submit. So we're finally reaching the we're finally progressing to where I was before this new learn Kotlin live, because I was here. So this is the last question that I have already fixed. But so maybe actually this is why I felt like I had already half that question fixed, because this is actually I have already finished this one, right? Have I? Have I not? That is exactly why I already have the feeling that I have already fixed that. Fixed the last problem. I mean what is it? matrixElementsSum, because maybe I have already fixed it in some early episode. Have I? Let's see. In episode 5, where were I when I was taking the episode 5? Please allow me for one more minute, but seems like yeah, I have already. This is the second time I've written this question. Sorry for that. I was right back from long way. I went to the United States for traveling for business last week. So yeah, so actually this one is solved too. Is it? Should never happen. This really sounds like, yeah, I think down to is something I learned during this streaming lesson. So I believe this one is solved during live. So yeah, we're happily starting a really brand new question. So I hope I can solve it really quickly, so we can stop here today and we can talk about the we took a look at fill, but I think we need to take a deeper look at how these functions are used, because yeah, I think they are kind of like static library, but they are not. So let's take a deeper look into this tomorrow if we have time. So first of all, let's given two strings, find a number of common characters between them. Oh, this one is simple. So actually this is something I think I have encountered during a Google on-site interview, I guess. I don't know, maybe. Yeah, it looks really like the question that I have encountered, but I'm not 100% sure here, but actually I'm not sure if I'm supposed to say that too, but haha. Let's take a look at the question. Let's see. So yeah, because A and C are common elements between these two A's and one C, so yeah. So to do it really intuitively, I will have two hash maps to do it really intuitively, but I believe is not optimized, is to have two hash maps and iterate through the elements in these hash maps. The two hash maps will each contain the element that is in this string, the first and the second string. And like, for example, the map is going to be like A equals to 2 and B equals to 1 and C equals to 2 and in the later it's going to be a equals to 3, d equals to 1, and c equals to 1. And then we compare these, it loops through these elements for item in map 1 and for item in map 2 if item dot key equals to item, that's item 2 dot key sum plus equals math dot min item 1 value and item 2 dot value. Yeah, this is the a naive way to solve it. Maybe that is not that naive, because the super naive way is to for item 1 in S1 for item 2 in S2. Wow, this is actually easy and not easy. Remove S1 if item 1 equals to item 2. Remove S1 and remove S2 and sum plus. Actually, I don't know. Maybe this performs even better than this one, because we need to first allocate the we need to first collect these, iterate through the string 1 and string 2 and collect these two. And these two structures are actually not, we can use a tree map for this, but it is still not optimal. It's going to take log n to search. Are we going to search at all? Maybe we can use, instead of iterating, we can search here. But search and iterating are going to have the same performance, because they're all going to be log n. I think so. Is it? Iterating through a list map is log n. Is it? It's n log n, right? I think it's n log n. I'm not sure about that. So anyway, these two are both not optimal. Maybe this one is actually closer to optimal. So actually, yeah, a way to do it is to match a really yet another naive way to solve it, but probably faster than this one. I don't know. This is going to be n times length of S1 times length of S2, and I think I can think up of one that is math of max S1 log S1 and S2 log S2. So that is first sort them A, B, C, C, and sort it into A, C, D. And then we can match each item here, match, remove, and this is no match, so each caret would, the one with the smaller caret, the one with the smaller character move forward. So this is here, and this is here, so still no match, and this one with the smaller character move forward, and it's 2C, so it's match again. And yeah, this is actually, let's look at a slightly more complex one. Okay, I'm going to talk about the algorithm today, and maybe we implement it tomorrow. A, B, C, D, G, HZ, Z, DD, GG, let's play GGG. And BBAA, no BBAA, BBCCC, D, 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 E, F, G, H, I. So, wow, this is an example that someone have demonstrated to me that I think it was during some material that they have said that you better first think up of a size of a test case that is not very simple, that is complicated enough, but that is also not an edge case. So this is some mistake that someone would make. Like if you're making them of the same length, this is actually a special case. So let's do it this way. So we start with AB, and A is smaller, so we again move it forward to here. So now it's B and B, and there's a match. So it's B, and then B move forward. Both move forward here, here, and here. And then B is smaller, so move forward. And C, there's a match, so move forward again. And then let's move forward again. C and D, no match. C increase and until D, and that's a match. So D again, and advance. That's also a match. So advance again, and that's again a match. Advance again, and advance again. So no match. D goes through E, then F, then G, and that's a match again. G, H, G, no match. G, 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 H, match, then Z. So yeah, I think this one is implemented correctly. So, and I also think that if these two strings are already sorted, then this is the optimized way to solve it already, because it only takes up n plus n. I mean s1 plus s2. It's linear. So this would be the optimal way to solve this one, but it is not sorted. So actually now it's log s1 log s1 log s1 plus s2 log s2. Actually it's already pretty fast, so it's max of s1 log s1 and s2 log s2. It's actually pretty awesome already. So I think we can implement this one tomorrow, but first of all, let's challenge ourselves to think if there is yet another better way to implement this one. Let me think about it. S1 log S1. So if we're not sorting it, we're definitely putting them into a map. At least that's what I'm thinking, because we need to organize it. Maybe not a map, because it's the character itself is because map is performing not that well when looking looking up inversely. So maybe we can just use the array. So it's going to be array of size 26, which is definitely acceptable. So we're going to have something like, we have 2 A's, 1 B, and 2 C's, and 0 blah 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 blah. And then we have 3 A's, 0 B, 1 C, 1 D, blah 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 until Z. So to compile these two libs, we need S1 plus S2 because we need to go through every item. And then we need to 26 to go through these items, and for each item we're going to be linear because for every time we just simply check math.min S1 let's call it array1 I and array2 I and add them to the sum. So this is actually so much easier. Then this complexity is big O of S1 plus S2 plus 26, which is simply goes to big O S1 max of S1 and S2. So yeah, I think we have found the most optimized solution. Let's write it tomorrow, or maybe we can do it now. I don't know, because we started late, so it's actually, yeah, maybe. I don't know if I'm going to embarrass myself by trying to finish this so promptly, but hey, let's do it then. So we need an array of integer Kotlin integer, and it's a value. It's array1 of type array integer. I don't know, is it this way? I don't know. How is it? Oh yeah, it's that way. And value array2. So for that's one. Yeah, I think we can iterate this way, right? Character and that's one. How do I initialize an array in Kotlin? I think it's the length of it, right? Oh, here's arrays. The length of it, right. Can we initialize it with the length of it? I hope so. Is this the initial length? Whatever, let's just do it. Yeah. No, not 5. So of lowercase English letters, so we can use 26 here. Wow, these are magic items though. For real coding, for better software engineering, we better write something like the length of array equals 26 here, but yeah, we're not going to do that. Oh, actually, I don't know how we write constant, so maybe we can talk about how we write constant tomorrow in Kotlin. Character in S1. Minus a array2 and var sum that's equals to 0. Index in array1 dot indices sum plus equals math dot, is it math? I forgot it again. What's it in Kotlin? Kotlin math max. I think it's math. I think so. We're using it directly. I don't know if that's a correct way. And array2 of index and return sum here. (26). So yeah, we don't pass the length of the how is it going to know the length anyway then? Mutable array? I don't know. Array size, yeah, it's need no value. Size and size and init. So it actually needs it. 26 and it initialized to 0. Initialize. So this is just my guess. I don't know. I don't know if it works this way. Let's check. Array Kotlin init and its size and init. Yeah. Integer literal. So it's int 0. Is right. I hope it's right. Because I'm tired already. Oh, yeah, this is also some magic number here, so this is also not preferred. Can't access init, so how do we make a int here? Maybe it's value of or something like that. Compared to hash code minus mod or plus range times to char, no, not to, from. Convert down to range to, no, these are not, nothing, not the thing that I'm expecting. Interesting, there is no constructor for it, but there's no constructor for it, but init function. Init function. So it's actually I'm not very familiar with lambda here, but it looks like it's not quite what I expected. Here it is, init functions. Here's the init functions. So so yeah, this one is the can be used to create an array of a given size field with new elements. Is no elements going to be like so? Yeah, because yeah, of course. So array of. So actually we got a I here, but where does this I come from? It's from external, so okay, so we're actually just doing the I to I function. Now I know. Oh no. So this is a init function. We're going to init it with 0 at all times. Expecting 0. Why? Where is it expecting 0? I. So do I need bracket for this lambda here? I'm so unfamiliar with Kotlin lambdas. Just to make it explicit. Maybe. Candidate is applicable because of receiver type mismatch. Yeah, there is no .max. So yeah, this is yet another mystery that is unsolved. But array of integer, no. Yeah, it's an array of int, so why? Still mismatch? Really? .max. Why is it mismatching? None of the following blah 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 blah. int.max. Really? I think I have solved this one. Some questions with 0 earlier. So let's try CodeSignal.com. Let's take a look at some other questions I've solved earlier. Intro. What's that? Or was that max? I'm trying to find max. Is there even a max? No, not this one, of course. Century from Europe, maybe this one. Max. No, no max. Age of the ocean. I think this one. Yeah. Ah, Kotlin.math.max. So math.max. But I think it's going to say, it's still going to say there's no match. Because I think math and int are like some kind of alias. Unsolved reference, because I'm not using the full name here. What's the full name? Kotlin. Who've joined me? Happy? Happy to have you. I think it's Hongjin Chung, I guess. So let me take a look. Hi. Yeah. Hi, Hongjin. So yeah, it's not correct here. It's 5. Why? Oh, because it's math.max. But max. Yeah, max should be 0. Math.min. Ah, that's a reason. I think we've solved it. Now that. No. Have not nailed it. Why? It's init to 0 for all cases and aha, S2. This is stupid. Okay, passed. Let's call it a day then. Yeah, then maybe we can talk a little bit about lambdas tomorrow, and also we probably can talk about this Kotlin.math.mean and the one that we used, the fill we've used earlier. Oh, who's this? I don't know. But yeah, great work. This is one problem this week. Yeah, I'm finally solving a new problem. Yeah, that's... What's a PD1? What's a PD1? What's a PD1? Oh, you mean your ID or I don't know. My profiles? Okay, I don't think it's a good idea to show you all my friends, so... Hi, Donkey Fool. Maybe see you tomorrow then. Yeah, that's all for today. See you.